Hello everyone, I'm going to try to do this multivariable calculus problem where we find the volume of a solid using a triple integral. And so first of all, I'm going to try to convey what the solid is through a picture. And we're going to break this down into pieces. Let's see. So what we have is a cylinder y equals x squared. So I am going to first of all draw it without using this little snapping pen program here where I'm just going to draw freehand. Sometimes I think it's easier for me. So sometimes when I use the drawing program, it surprisingly doesn't come out quite as well. But okay, well all right, so there I have that picture there. Okay, so see this right here is y equals x squared in the xy plane, and it's a cylinder, meaning that here's x equals y squared. It doesn't have z in the equation. So what happens is that this it's not a circular cylinder. It's a cylinder meaning that it goes up like that, where it forms these rulings with the xy plane. So well, that's one of the shapes there. So maybe I can color that in. But that's just a surface. And then maybe I'll color the other side of the surface slightly different color. And then, okay. Now there's also z equals 0, which is the xy plane. That's down here. And well, let's hold off on that one. Then there's also y plus z equals 1. Now y plus z equals 1 does not contain an x variable in that equation. So let's talk about that. Well, if I have y plus z equals 1 in the yz plane, that is a line. So let me just draw that line, but it's not very bright, is it? Let me just draw the line like that. So this is y plus z equals 1. Easily to see is that if I have z equals 0, I get y equals 1. And if y equals 0, I have z equals 1. So that extends, though, as a plane because the way to understand that is that there is no piece that is given by x. All right, let me try to draw it like this then. Okay, I think that's a little closer to what I want. So that plane is going through there. And so that, in my opinion, does not look very good. Looks sort of not like pretty poor. Okay. And then we have on the base of this, we have z equals 0, which is this plane down here. Okay, so what if I just colored all these in? I have a feeling it's still not going to come out that good, but all right, so here, okay, what's going on then is that this is going to cut like that. It does seem to be improving a little bit. So I like that idea that it does. I'm working the picture, and it's starting to come together. It's always sort of a cool idea, sort of an art, you know. In fact, I feel like I don't know. I might even erase that part. But anyway, let's not get hasty. Okay. I really don't think I'm explaining, right? I'm just drawing this thing here. So what's going on then? Okay, so we have these three planes. And the final shape I'm going to just draw right now. But I'm going to freehand it sort of. It's like this. Okay, So here's x, and then y is coming like this, and then z up here. Then, okay, this top part, I'll color in this, I don't know, this sort of weird color that I made for myself. Looks like mud, really. Okay, so, okay, this top part here is x plus y, no, y plus z equals 1, which is the same as z equals 1 minus y. And so see, z is bounded from above by 1 minus y. And then down below on the bottom is z equals 0. And so that's the lower bound of z. And then, all right, this whole thing, as you can see, but maybe I'll try to sort of ruin this picture here if I can by adding on it has, yeah, oh well, yeah, I am sort of ruining it. It's actually more like this. Well, not really. The question is why should I care that much about this? Okay, so anyway, maybe it's like that. Okay, so see the base there is D, and as we know, as it says, that we have y equals x squared. Down here. Now, okay. Now what happens with this equation here, y plus z equals 1, is this plane here is the xy plane. And in the xy plane, when I have y plus z equals 1, this is z equals 0. That's the plane, xy plane. And so I get y plus 0 equals 1, so I have y equals 1. And that is this piece up here. And this forms the region D. So that's D, and then we see then from D that y is bounded from above by 1 and below by x squared. And then finally, x goes from 1 to negative 1. Okay. So this is our integral. This is our region, our solid region D. And what we're going to do is we're going to find the volume by integrating over E of just the constant 1. That's how you find the volume, is you integrate 1. And so this is going to give us the integral from negative 1 to 1, and then from x squared to 1, and then from 0 to 1 minus y of 1 dz dy dx. So what I'm doing is I'm picking up z, y, x, and I follow those order, and I just pick up the bounds. And so maybe we're almost done. Well, not really, but still, it's a good start for sure. So, but I think we can do this integral. The integral of 1 dz is just z, and we go from 0 to 1 minus y. In fact, I didn't have to do quite as much work. It's a constant. You multiply the constant by the top bound minus the bottom bound. That's a well-known. See, if you integrate from a to b, a constant, say dx, this is cb minus a. So if you look at this situation, I have 1, the constant, dz, and I take 1 and I multiply by 1 minus y minus 0. So you can just shorten your work there. Okay, so this is just something where I can make a mistake just by not paying attention, but I should be able to get this. So the integral of 1 is y. The integral of y is y squared over 2. I value from x squared to 1. So this will give me negative 1 to 1. I plug in 1. I get 1 minus 1 squared over 2. Subtract, plug in x squared. So I have x squared minus 1/2 x squared squared. Lots of parentheses there. Dx. So this is the integral from negative 1 to 1. 1 minus 1/2 makes 1/2. Minus x squared. Minus a minus makes plus 1/2. X squared squared is x to the 4th. Dx. These are all even functions. So when I go from negative 1 to 1, if I want, and I do want, I'm going to go from 2 times 0 to 1, and I'm going to integrate. You don't have to do that, but it's something you can do with even functions. Symmetry. So you have 2. 1/2 integrals with respect to x is 1/2 x. Then we have x to the 3rd over 3 minus 1/2 x to the 5th over 5. See, the reason I like to do this little trick, negative 1 to 1, when I have even functions, is that especially for polynomials, it's easy when I plug in 0. So putting in 0 just makes 0. So I have 1/2 times 1 minus 1 to the 3rd over 3 minus 1. Okay, 1/2 times 1/5 is 1/10. 1 to the 5th, and all that just minus 0. So this is 2, 1/2 minus 1/3 minus 1/10. So this is 2 getting a common denominator of 30. I mean, there's a bunch of little ways to simplify it. So I'm just going to get a common denominator of 30. So I get 15 over 30 minus 10 over 30 minus 3 over 30. And this makes 2. 15 over 30 minus 13 over 30. Oh, darn it. Okay. I think it's right. Okay, yeah. So it's too much stuff. I don't want to get it wrong here. All right. So then I have 2 over 30. Oh gosh, redo the whole video. I can't believe I have to do that. So what happened? So 15 over 30, 10 over 30. Well, my mistake is over here. Sorry, I didn't really have the best day. I've been making a lot of little mistakes. It's a plus there. Okay. So, keep going, for sure. Don't give up. All right, so I have 5 over 30 plus 3 over 30, 8 over 30. Then this reduces a bit. Well, one way or another, you get to your answer. Okay, that last part was I think this is good. Practice all fractions and etc. And then I these problems are long, and unfortunately, I'm just not happy with that I make tiny mistakes, and maybe you saw it. I just right there. You have to put pause there. I mean, there wasn't any concept there that I got wrong. It's just didn't get that right. But the more difficult part for sure is this picture. And so maybe a question is, well, do you have to draw the picture? Is there any way that you can sort of not do that? I'm sort of going to try to improve my picture though. Can you get away without doing that picture? Probably. I mean, maybe you can just from here look at this being just this right here. This can be written as z equals 1 minus y. So that seems to give this piece over here. And then y equals x squared. Okay, that's of course easy enough, but and you write that down below here in our XY plane. It's a little bit something we should know, but when you have z equals 0 intersecting y plus z equals 1, you put in z equals 0 and you get y equals 1. That gave us that top part. So I think we can do this, and then, yeah. But lots of fun. I'd say this picture is like a rough draft a bit. I had pieces that were good, but then I didn't even label it, did I? So this is all these little places here. This is y equals x squared is that cylinder there. And then this cylinder here, or this plane is y plus z equals 1. Okay. All right, well, you could like it, this video. That'd be nice. You could leave a comment. You could subscribe. All right, you all. Okay, let's see what I can do with this. Do you know about keyboard shortcuts? It's pretty awesome on the iPad, iPhone, probably other devices. So I have this keyboard shortcut of the shrug emoji, ASCII emoji. All right. So, okay, that does it. You all take care. Bye.